Good afternoon, everyone. I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I'd like to discuss the problems on vector integral theorems. So, as we know that there are three integral theorems. One is Gauss divergence theorem and Stokes theorem, and other one is Green's theorem on a plane. All the three theorems are the transformation between one integral to other integral. There are three types of integrals in vector integration: line integral, surface integrals, and volume integrals. Integral over the curve C f bar dot dr bar is the line integral. Integral over the surface S f bar dot n cap into ds, where n cap is the unit outward normal vector, is the surface integral. Similarly, integral f bar dv over the volume V is the triple integral or volume integral. So these theorems use the transformations between the line integral and surface integral, line integral and double integral, and surface integral to volume integral. So now we go through the theorems. Already we have seen several problems on the three theorems. Just I want to go with the problems using the three theorems. So before that, I will explain briefly the theorem statements. Gauss divergence theorem. It is a transformation between the surface integral and volume integral. And it is integral div f bar dv is equal to over V, where V is the volume bounded by the given region, is equal to integral over S f bar dot n cap into ds, or n bar is the unit outward normal vector. So keep in mind this relation, integral div f bar dv over V is equal to integral over S f bar dot n bar into ds, where n bar is the unit outward normal vector. This is the Gauss divergence theorem. So Gauss divergence theorem gives the transformation between surface integral and volume integral. The next theorem is Green's theorem in a plane. Suppose this is a transformation between line integral and double integral, and suppose if x and y is the given axis coordinate system, and assume that this is the region R bounded by the curve C, where C is the closed curve, where m and n are functions of x and y which are defined on the curve in the region. Then by this theorem, integral over the curve C m dx plus n dy is equal to double integral over the region R dou n by dou x minus dou m by dou y dx dy. So it gives a relation between line integral and double integral. So here the entire function is defined in the two-dimensional space only. The curve is bounded by this is the curve. We have to evaluate the line integral along this curve, along the closed curve C, and the region is, this is the region, and we have to consider the region R and evaluate the double integral based on the limits of the integration. Here the function is to be taken as dou n by dou x minus dou m by dou y. Here m dx plus n dy. So this is called the Green's theorem. So most of the problems are verification problems and finding the values using the one of the theorems. That is, those are the main aspects in these topics. And the last one is Stokes theorem. So what is Stokes theorem? It is a transformation between line integral and surface integral. So integral over the closed curve C f bar dot dr bar is equal to integral over S curl f bar dot n cap into ds, where n cap is the unit outward normal vector. So each time I will call the theorems whichever is asked in the examination or in the question bank. I will call these statements and we will go through the problems. So now see the different problems. Verify Stokes theorem for the given f bar is equal to this one, integrated round the square in the plane z is equal to 0, whose sides are along the lines x0, y0, x is equal to a, y is equal to a. Here we have to consider the Stokes theorem, and here it is given as a square. This is y x-axis means y is equal to 0. This is x is equal to 0. This is x is equal to a, y is equal to a. This is x and y axis. And here we have to verify the Stokes theorem. It is a relation between Stokes theorem. We know that. What is the Stokes theorem? It is a relation between, I will show that. What is the Stokes theorem? The relation between line integral and surface integral. Line integral and surface integral. So in this you need to calculate integral f bar dot dr bar. F bar already given, dr is dxi bar plus dyj bar, because the curve is defined in xy plane only. Similarly, you have to calculate curly f bar dot n cap into ds. Now I will go through the problem. Just I will take the problem number 1. I will take this problem as the, I'll go through the problem. Verify Stokes theorem for the function f bar is equal to, see the first problem. The first problem is Stokes theorem verification problem. Second problem is Gauss divergence. Third problem again Gauss divergence theorem. And fourth problem is Green's theorem. And again fifth problem is evaluated by Green's theorem in a plane. Right. So in this session we will solve some problems on these 5 problems. Remaining you do at your own. You take it as a practice problems. Now I will start with the first problem. Verify Stokes theorem for the function f bar, x square I bar plus xyj bar. I will call it easy. First problem solution. What is given? F bar is equal to x square I bar plus xyj bar. This is the given function. The given region is bounded by the square, the x-axis, y-axis. This is y is equal to 0, x is equal to 0 because it is the y-axis, and given it is x is equal to a and it is y is equal to a. So the region is to be considered as the closed curve, that is O00 to a comma 0, then b a comma a, and c 0 comma a. So we need to consider along OA, along AB, along BC, along CO. So we have to consider all the directions, all the segments OA, AB, BC, CO to evaluate the line integral. And to find the surface integral, we need to consider this region capital R. This is called the capital region R. And this is the curve C, closed curve is C. Right. So now by Stokes theorem, what we know that I will write by Stokes theorem, integral over the closed curve C, f bar dot dr bar. What is the statement? Integral f bar dot dr bar around the closed curve C is equal to integral over S curly f bar dot n cap into ds. Curly f bar integral over S curl f bar dot n bar into ds, where n bar is the unit outward normal vector. So to verify this theorem, we have to consider the left hand side term and we have to evaluate, and then you have to go for the right hand side term and then you have to evaluate. Now consider LHS. The first one, consider LHS. What is integral along the closed curve C f bar dot dr bar? That means what? This is the curve C. This is the curve C. That means what? You can split this is integral over OA bar along OA f bar dot dr bar plus along AB f bar dot dr bar along AB plus along BC f bar dot dr bar plus along CO f bar dot dr bar. So these are the 4 integrals you have to evaluate along OA, along AB, along BC, along CO. So one by one I will evaluate. So first one, integral along OA f bar dot dr bar. What is f bar dot dr bar? So here I will calculate f bar dot dr bar. What is f bar? X square I bar plus xy j bar dot product with dx I bar plus dy j bar. That is x square dx plus xy dy. That is f bar dot dr bar. So integral x square dx plus xy dy over the along the curve OA. So what is the equation of OA? Here, what is the equation of OA? Here, OA equation is y is equal to 0. That means dy is 0. Along OA, the equation y 0, dy 0. But x is varying from 0 to a. X is a variable. It varies from 0 to a. So, if you do along one direction, along OA, you can solve along AB, along BC, along CO in the similar way. So, I'll explain. It is along OA, x is a variable. It is varies from 0 to a. So, x square dx you put as it is. And second term, x into y0 dy 0. The entire term is 0. So, what is the integration? X cube by 3 between 0 and a. That is a cube by 3. That is the first integral. The first integral is a cube by 3. Call this is number 1, equation number 1. I hope this is clear. Integral f bar dot dr bar along OA. Along OA equation is y0. So dy 0, but x is a variable. It varies from 0 to a. Now, what is the second value? Along AB. Along AB. What is along AB? This is along AB. What is the equation? X is equal to a, but y is a variable factor from 0 to a. So here the equation is x is equal to a. Here the equation is x is equal to a, or dx is equal to constant derivative 0. But y is a variable. Y varies from 0 to a. Y varies from 0 to a. But y is a variable. It varies from 0 to a. Now, integral along AB f bar dot dr bar is equal to integral along AB. What is f bar dot dr bar? It is a common. X square dx plus xy dy. X square dx plus xy dy. That is integral y varies from 0 to a. Y varies from 0 to a. So x is equal to a. So a square dx means 0. The first term, entire term 0. X is equal to a y dy. The first this is equal to integral 0 to a. First term entire 0. A constant y dy. So what is integral y? Y square by 2 between 0 and a, or a by 2 into a square minus 0. By 2 I'm taking outside. Upper limit a square, lower limit 0. That is a cube by 2, and this is called the second integral, line integral along AB. I hope this is clear. If you observe this, you can do any problem in finding line integral. Then what is third one? Along BC. Along BC. This is along BC means this is OA, AB, along BC. So what is the equation of BC? Given y is equal to 0. Y is equal to a, sorry. This is x is equal to, sorry, y is equal to 0 and y is equal to a. This is x is equal to 0. This is x is equal to a. Already we have taken x is equal to a along AB. Now along BC, the equation of the line is y is equal to a, or we call it as dy is equal to 0. The equation of the line is y is equal to a or dy is equal to 0. But here x is a variable factor. This is a comma a and this is 0 comma a. X varies from a to 0. I have to take the direction also. So x varies from a to 0 because it is moving in this direction, a to 0. So x varies from a to 0. Therefore, integral along BC f bar dot dr bar is equal to integral along BC x square dx plus xy dy. So here y is equal to a, dy is equal to 0. Second term and complete term 0. Only first term gives the value x square dx from a to 0. Not 0 to a to 0. There is a negative symbol is difference. So that's why you take it as a to 0. So what is the integration x cube by 3 between a and 0, or upper limit 0 minus lower limit a cube by 3. So the value is equal to minus a cube by 3. Call it is equation number 3. Minus a cube by 3 one value. A cube by 2 is other value. And first value is some other value. So next, what is the last one? Along CO. Along CO means here the equation is x is equal to 0 because it is y axis. Now I will write similarly along CO. So here what is the equation? Here the equation is x is equal to 0. So dx is equal to 0. Therefore, integral along CO f bar dot dr bar is equal to along CO. What is the function? Just I will see x square dx plus xy dy. So x 0 means the entire term 0. You no need to find the limits of integration. Here it is integral 0, that is equal to 0. So third, fourth one is 0. Therefore, integral f bar dot dr bar along the closed curve C is equal to, what is the first value? I will go through one by one. A cube by 3 is the first value. See the equation number 1. A cube by 3, second one a cube by 2. A cube by 3 plus a cube by 2. And what is the third value? Third value is minus a cube by 3. Minus a cube by 3 plus 0, last value. So in adding along OA, along AB, along BC, along CO. So in adding all the values, you will get the a cube by 2. This is equation number, Roman number 1. This is the major value because we have calculated the LHS. This is left hand side term. So to verify the theorem, we have to verify this equation value is equal to the right hand side equation value. So integral f bar dot dr bar along the curve C is equal to a cube by 2. So up to this clear, I hope. Now consider what you have to consider. RHS, integral curl f bar dot n bar ds over the surface S. So here what is curl f bar? Here curl f bar is del cross f bar. I hope this is right. Am I right? Curl f bar. This is to be calculated. N bar is to be calculated, and you have to consider the projection also to find ds value. So what is curl f bar? What is f bar? X square I bar plus xyj bar. X square I bar, I will write here x square I bar plus xyj bar. So del cross f bar, I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, and this is x square xy 0. So what this is I bar into, this is 0, this is 0, minus j bar into 0, 0, this also 0, plus k bar into dou by dou x of this one, that is y, minus dou by dou y of this one, this is. So the value is equal to y into k bar. The value is y into k bar, f bar, curl f bar value y into k bar. And what is n bar? N bar is the unit outward normal vector. So here it is a two-dimensional space. It is xy. The outward normal vector will be in the direction of z-axis or positive z. So I can write n cap is equal to n bar is equal to k bar. Simple. No need to calculate. Just you can observe from the figure n bar is equal to k bar. K bar by magnitude of k bar is 1. So n bar is equal to k bar. Then curl f bar dot n bar. Curl f bar dot n bar. That also I will write here only. Curl f bar dot n bar is equal to curl f bar is yk bar. The dot product with k bar, that is equal to y. Curl f bar dot n bar is equal to y. Now RHS. Now RHS is equal to integral over S curl f bar dot n bar ds. So because of the projection is considered in the xy plane, what we will get? Dx into dy. And what is this value? Curl f bar dot n bar value y, double integral over the surface S, y into dx into dy. Because it is the n bar dot I bar k bar is 1, that is denominator 1, no issue. So here, because it is a square, x varies from 0 to a and y varies from 0 to a. So the limits of integration are very simple. X is 0 to a and y also varies from 0 to a, y dy dx. All are constant limits. The integration is carried out irrespective of the limits of integration. You can do first y then x or first x then y. Integral 0 to a y square by 2 between 0 and a dx. Or this is a square by 2, lower limit 0, integral 0 to a dx. So this is a square by 2, integral dx is x between 0 and a, or a square by 2 into a minus 0, that is a cube by 2, call this is Roman number 2. RHS value a cube by 2. And what is LHS value? LHS value also a cube by 2, that is equation number 1. And right hand side value also a cube by 2. Therefore, LHS is equal to RHS is equal to a cube by 2. That means what? The Stokes theorem verified. That is the required solution. Stokes theorem is verified. That is the required solution. So I hope this is clear. Just I will go through it. So this is the entire problem. So you need to solve that, then only you will get some idea about that. So this is the square. You have to evaluate the line integral as well as the double integral. In line integral, you need to go along this curve. In double integral, you have to consider the region bounded by this curve. So for y0 to a, x0 to a, this can be obtained by taking the strip inside the region. y0 to a, x0 to a. Then the limits will be the constant limits, so that the integration is carried out with respect to the constant limits. So you can do integration first with respect to x or y or whatever it is you want, you can do that. So no problem. So in this way you can solve the problem of doing verification of Stokes theorem. Right. Now I will go to the another problem. So what is the other problem? See once here. So verify Gauss divergence theorem for function f bar is equal taken over the surface of the cube bounded by the planes. So here the given region is the cube. Cube means what? It is a three-dimensional figure. It is the cube, x-axis, y-axis, z-axis. So this is called the, what is this? This is the YZ plane. YZ plane means what? X is equal to 0. So this plane is x is equal to a plane. You observe this, these two are the opposite. Y is equal to 0, x is equal to 0 because it is YZ plane, x is equal to 0. The parallel plane is x is equal to a. Similarly, you can consider this plane, the backside plane, this plane. This plane is XZ plane. XZ plane means the plane equation y is equal to 0. They are already given coordinate planes and these planes. Y is equal to 0 means the backside and y is equal to a, that is the front side plane, the parallel plane. This is y is equal to a. So the boundaries are x is equal to 0, x is equal to a, y0 backside plane, y is equal to a is the front side plane. And what is the other plane? Z plane. XY plane means z is equal to 0, the base plane. So you observe this is z is equal to 0 and the top, this is roof, z is equal to a. So this is the given cube. You need to evaluate the triple integral along this one. That means x0 to a, y0 to a, z0 to a. All are constant limits. So what is Gauss divergence theorem? What is the statement of, you have to keep in mind all the three theorems. Then only you can solve the problems under Gauss divergence theorem, under Stokes theorem, whatever it is. So what is Gauss divergence theorem? So here I will show that integral div f bar dv is equal to integral f bar dot n bar into ds. So that I will write here. So to do the second problem solution by Gauss divergence theorem, we have integral f bar dot n cap ds is equal to integral div f bar dv. Div f bar means del dot f. What is div f bar? Del dot f bar. It is the surface integral. It is the volume integral. The given region is the cube. So already we have discussed what are the different planes in the cube x, y, z, and x varies from 0 to a and y varies from 0 to a and z also varies from 0 to a. Z0 means in 3-dimensional it is xy plane. Y0 means it is called xz plane. Z0 means it is xy plane. X0 means it is yz plane. So in 3-dimensional vision, x0 indicates the yz plane and y0 indicates xz plane, z0 indicates xy plane. So integral f bar dot n cap ds, the outward normal vector. So here it is OA, BC and DEF, G. So here there are 6 faces. You have to evaluate along OA, BC, along DEFG, DEGF, similarly along FGBA and the line integral along OCED. Like that you have to evaluate the surface integral along with all the 6 planes. So triple integral is integral div f bar. What is f bar? First you see the f bar. What is f bar value here? X cube minus yz I bar x cube minus yz I bar. And what is the second term? Minus 2x square y minus 2x square y j bar plus what is the last term? The last term is zk bar plus zk bar. So what is div f bar? Div f bar means del dot f bar, that is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with x cube minus yz I bar minus 2x square yj bar plus zk bar. So dou by dou x of this one dot product, that is 3x square only, plus dou by dou y of this one, that is minus 2x square only. Y will become 1. K bar dot k bar 1. Dou by dou z of z, that is equal to 1. So what is the value? X square plus 1. That is div f bar. Now I am considering RHS. What is RHS? Integral div f bar dv over the region V is equal to triple integral x0 to a, y0 to a, z also 0 to a, The function div f bar is x square plus 1. dv means dz dy into dx. So x 0 to a, because it is a cube, all values must vary from the same limits to same limits. 0 to a, 0 to a, 0 to a, because all are having equal lengths. Length, breadth and height, both all are same. So now on integrating with respect to z first, you can integrate yourself, no problem, because all the limits are constant. Limits x square plus 1 is constant, and it is z varies from 0 to a and dy dx. So what is the value? 0 to a, 0 to a, and it is a minus 0, a constant, x square plus 1 dy dx. So again on integrating with respect to y, a into a square, 0 to a x square plus 1 into dx. So I write here a square into, no problem, x cube by 3 plus x between 0 and a. That is a square into a cube by 3 plus a minus 0. Or this is the a power 5 by 3 plus a power 4. This is the RHS value, a power 5 by 3 plus a cube. I will write here a power 5 by 3 plus a power 4. This is RHS. It is integral div f bar dv over the volume V. That is called Roman number 1. RHS is a power 5 by 3 plus a power 4. So this you have to verify with LHS. What is LHS? LHS is integral. What is the function? F bar dot n cap ds along the cube V, along the cube S is equal to integral along, what are the faces you see? OABC, that is one surface. Along OABC, one surface. What is the opposite surface? OABC is the base surface, base plane. The opposite plane is DEGF. I will write everything. DEGF plus. So, two planes finished. Now I am writing OCED, one plane, OCED, integral along OCED plus integral the opposite plane. What is the plane? It is ABGF plus integral. Again, what is the value? So these two are over, and back side, front side also over. Back side, top, lower over. Now back side, OAFD. And what is the last one? OAFD, last plane, OAFD. Front plane, BCEG. So to find the surface integral, you need to consider all the 1, 2, 3, 4, 5, 6 faces. You have to evaluate the integrals along the surfaces. So for OABC, I will write here for OABC, and for DEGF, and for OCED, for ABGF, for OAFD, for BCEG. I will write one by one. So what are the equations? What are the outward normal vectors? Those things are important. For OABC, what is the outward normal vector? For the surface OABC, the outward normal vector will be in the direction of negative z-axis. So minus k bar. N bar is equal to minus k bar. And here n bar is equal to plus k bar. For the surface DEGF, I will show it. For the surface DEGF, the outward normal vector will be in the direction of z. So this will be k bar. Similarly, for the surface OABC over, this is also over. Now go to the OCED, the outward normal vector is in the direction of negative x. So this is minus I bar. OCED, OCED, this is. So the outward normal vector is OCED. This is OCED. The outward normal vector is negative x-axis. So this is minus I bar. And like for the surface ABGF, the outward normal vector is in the direction of positive x-axis. So this is n bar is equal to I bar only. So what is for the surface OBFD? Not this is OAFD. I think OAFD. The outward normal vector is minus K bar, minus J bar. OBFD. The last one BCED. What is BCED? You see here BCED. BCEG, I think. BCEG. The outward normal vector is J bar. Plus J bar. So these are the corresponding outward normal vectors with respect to the given function. So now what is F bar? So F bar is, we know that x cube, I will write here, F bar is x cube minus yz into I bar minus 2x square yj bar, 2x square yj bar plus what? Zk bar. Plus Zk bar. So now what is F bar dot n cap? F bar dot n cap. What is the value? So minus K bar ante this is minus Z only. F bar dot n cap is minus Z. And here F bar dot n cap. N cap or n bar both are same. N bar, n cap. N bar is the outward normal vector. N cap is the unit outward normal vector. So what is this Z? This is Z only. Here F bar dot n cap minus I bar. That means what? Yz minus x cube. And here I bar. I bar means F bar dot n bar is equal to x cube minus yz. And here minus J bar. Minus J bar means what it is? F bar dot n cap is 2x square y. N bar dot J bar, F bar dot n cap is equal to minus 2x square y. These are the different F bar dot n bar also. Now, what is the equation of OABC? What is the equation of OABC? I will show that. OABC equation. XY plane means Z is equal to 0. But X varies from 0 to A, Y varies from 0 to A. So Z0 means, so I will write here for this surface here Z0. Z0 means what? DZ also 0. But X and Y varies from 0 to A. Both are having equal limits 0 to A. Now this is integral, double integral 0 to A, the function minus Z and dy, am I right? Dy into dz. But Z0 means the entire limit 0. Z is equal to 0 here. This is Z is equal to 0. So integral Z dy dx means it is 0. So the first integral value 0. What is the second equation? DEGF. This is DEGF equation. The equation is Z is equal to A. So dz also 0. Z is equal to A constant. So dz 0. So double integral 0 to A. Here also 0 to A. Z dy dx. So this also 0. First value 0 and second value also 0. Now come to the third value. What is the third value? Minus I bar. Equation OCED. OCED is the OCED. The outward normal vector is minus I bar and it is YZ plane means the equation is x is equal to 0. So the equation is x0 implies dx also 0. So double integral, what is the value? I am writing here only. Double integral yz minus x cube, the projection in yz plane dy into dz, dy into dz. So n bar dot I bar is 1, so that you can not consider. So x here, x0 means this is 0. So only you will get yz only. Yz dy dz, I will write here yz dy dz. But y varies from 0 to a, z also varies from 0 to a. So what is the limit? On integrating you will get y into z square by 2, 0 to a, z limit. That means what? Y into a square by 2, lower limit 0. Again integral 0 to a, so y means y square by 2. So what is the integration 0 to a again? A power 4 by 4. That is the another value. A power 4 by 4. This value is a power 4 by 4. And what is this value? 0. This is 0. Here I am writing all the values. 0, 0, a power 4 by 4. Y square by 2. That is a square by 2. Z means z square by 2. Yz limit here. You can observe that yz limit. This is yz, y0 to a, z0 to a. So yz, y0 to a, z0 to a. So that is like that only. Now I will write freely because I am writing on the right hand side. The values will be very closer to you. Now what is the ABGF? What is ABGF? ABGF. This is ABGF. The outward normal vector is the equation is y is equal to a. ABGF, y is equal to a, dy is equal to 0. But here x is equal to 0 to a, but z also 0 to a. Am I right? So what is the value? Double integral x cube minus y into dx into dz. But y is equal to a. So this is a. So x power 4 by 4 minus ax between 0 and a. So a power 4 by 4 minus a square. Again it is integral z. dz means z0 to a, that is a power 5 by 4 minus a cube. A power 5 by 4 minus a cube. That is the value. X cube minus ax 0 to a. So substituting the limits, this is integral dz z between 0 and a. So a multiplied this value, a power 4 by 4. Similarly, you find the remaining 2 also and add the things. So then you'll get the value of RHS, LHS, and that is seen as a power 5 by 3 plus a power 4. Then the two values LHS and RHS are same, then Gauss divergence theorem is verified. So in this way, you can solve the problems on Gauss divergence theorem. In the next class, I will do the remaining problems also, or I will do in the question bank also. So see, note down the problems and try to solve the problems. And with these few problems, I conclude my lecture in this. The reference book is T.V.K. Iyengar, S. Ranganathan sir et al. Mathematical Methods by S. Chan Publishers in the year 2006. This book is published in the year 2006. So that also you can mention. So please note this book to verify more problems. And thank you.
Like, share and subscribe. Hit the bell icon for more updates.